Audiological system. This lecture presented by Lecturer Ibrahim Mahmood, Electrical Engineering Technical College, Middle Technical University, Baghdad, Iraq. The lecture presented to the third stage in Medical Instrumentation Engineering Technical Department. Today we have an audiological system. In this lecture, we will recognize the mechanism of hearing, classify the types of transducer in audiological field, and define the audiometer. First, we will discuss the mechanism of hearing. Sound waves are longitudinal waves in which the motion of each particle in the medium traveling moves backward and forward. This is the motion backward and forward along a line in the direction which the wave is propagated. The human aural system reacts to these oscillating pressure change and transmitting them to the brain through a series of steps. These steps done at an organ called the nerve. The ear consists of three parts: outer ear, middle ear, and inner ear. Sound is collected by an outer ear, which consists of an auricle and auditory canal. The sound is guided through the auditory canal to the middle ear. Arrive to the eardrum, which is flexible and circular membrane, start to vibrate when the sound waves strike it. The sound waves are passed by a movement of the eardrum to the middle ear. At the middle ear, there is the three tiny bones called ossicles: malleus, incus, and stapes. These tiny bones form a bridge between eardrum and the inner ear. Their interaction increase and amplify sound vibration further to the inner ear. In the inner ear, there is a cochlea, which contains several sections filled with watery fluid and contains hair cell. When the sound wave vibrates, the fluid begins to move and lead to the moving of hair cell, which begin to transform the vibration to an electrical impulse. These electrical impulses send to an auditory nerve and then to the brain, and the hearing occurs. There is two ways for sound conduction. The first one is the air conduction. By definition, it is the transmission of sound through the external and middle ear to the internal ear. The second is the bone conduction. Bone conduction, it is referred to transmission of sound to the internal ear mediated by mechanical vibration of the cranial bone and soft tissue. The bone conduction occurs at the mastoid process, which lies behind the ear. The mastoid process is the transferred sound to the internal ear and from the internal ear to the brain by auditory nerve, and the hearing occurs. Now, there is a very important concept in the audiological system. It is the threshold of hearing. We must know it. The threshold of hearing, we can specify it is the lowest level at which an observer can discriminate between the desired sound and the noise background. So, among the noise you fill in, you can recognize a lowest level. This is called the threshold, always present in the auditory system. In other words, it is the minimal intensity on the stimulus scale, with just barely adequate to elicit response. The base of each audiological examination is determination of hearing threshold. Now, we will discuss the type of transducer in audiological system. There is many transducer in audiological field: earphone, microphone, electret microphone, bone vibrator, and loudspeaker. All of us know an earphone. All the students have earphone. That's right. Earphone, they are usually made of moving coil type. They give a reasonably flat frequency response up to 6 kHz, after which their sensitivity falls rapidly. They are not specially designed for audiometric application, but for communication purpose. In their miniature form, they are used for hearing aids. This is the component of the earphone: wires, front case, coil, seal, magnet, transparent plastic cone, and the black case, which is the outer case. It may be noted that audiometric earphones are not interchangeable and must remain identified with a specific instrument to preserve the calibration. In conditions of ambient noise being too high for unshielded earphones, specially designed audio cups are used to exclude background noise, which will otherwise result to elevated threshold measurements. The second type is microphone. All of us know microphone. It is one of transducer used in audiological field. These microphones used to translate wave motion in air into electrical signal. There are many types of microphone. One of them, carbon bottom, which change resistance with the air pressure. Electrodynamic, where a voltage is induced in a coil by its motion relative to magnets. Condenser, where the capacitance of a condenser is varied by the vibration of the condenser plate. The high-quality condenser microphone of diameter 12.5, 6.25, and 3.125 mm are the most commonly used microphone, depending on frequency to be measured. For special purpose, microphone can be fitted to the air caps and used as a reciprocal arrangement to transmit sound of the air. Now, we will discuss how the microphone works. First step, number 1. When you speak, the sound wave, which is the mechanical wave created by your voice, carry energy toward the microphone, as shown in this figure. Inside the microphone, there is diaphragm, much smaller than you would find in the loudspeaker and usually made of a very thin plastic, moves back and forward when the sound wave hits it. So when the sound wave hits the microphone or the diaphragm in the microphone, there will be a movement of diaphragm backward and forward. The coil, this is the yellow one, the coil attached to the diaphragm moves back and forth as well. There is also a magnet. This magnet is permanent magnets produce magnetic field that cut through the coil as the coil moves back and forth through magnetic fields. So, by the assistance of coil and magnetic field, there is an electrical field occur. The electrical current generated and flow out from the microphone to the amplifier or sound recording device. You've converted your original sound to electrical impulse by using this microphone. This sound can be amplified by the current and then feed into the loudspeaker, turning the electricity back into much louder sound. The electret microphone. The electret microphone consists of a very light diaphragm, moving plate, and back plate, stationary or static place, and have a permanent charge implanted in electret material to provide polarizing voltage. The principle of operation of this electret microphone is that the sound wave is impinged to the diaphragm, cause the capacitance between it and backplate to change synchronously. This in turn induces AC voltage on the backplate. The AC signal is amplified in an amplifier which consists of a single JFET transistor with the gate connected to pickup plate. source connected to the ground and the signal appearing to the train. The JFET in the electret microphone designed for low noise application. The other type of transducer is the bone vibrator. The bone vibrator occurs through a mastered process. This part of bone vibrator located at the mastered process which lies behind the ear. In early days, bone vibrators were composed of rods connected to electromagnetically excited driving system. They were often held by hand against the mastered process. In the present form, the bone vibrators are of the hearing aid type, in which the transduction mechanism changes the alternating current into vibratory force through a diaphragm. Now, we'll discuss the loudspeaker. They are used to deliver auditory stimuli when it is not possible to have a close coupling to the transducer to the ear. Obviously, the acoustic energy loss into the surrounding will be much greater than when stimulation applied via the earphone. Basic audiometer. The audiometer is a specialized equipment. This is the audiometer. Specialized equipment which is used for identification of hearing loss in individuals and the quantitative determination of the degree and nature of such a loss. It is essentially an oscillator driving a pair of headphones. This is the headphone and audiometer, and calibrated in terms of frequency and acoustic output. Both frequency and output are adjustable over the audio range.